Alright, so in this video I'm going to show you how to draw the Lewis structures for 3 different compounds. The first one is CH3Cl. Then we're going to do NH3, which is ammonia. And the last one is H2O, water. So I'm going to follow the 4 steps that we learned in our notes for how to draw these Lewis structures. The first step is to count the total number of valence electrons. So to do that, I have to look at the atoms that are in this molecule. So we have carbon, hydrogen, and chlorine. Carbon is in group 14, so it's going to give us 4 valence electrons. That's the last digit of the group number, is 4. Hydrogen is in group 1, so it has 1 valence electron, but there's 3 hydrogens in this molecule, so we're going to multiply by 3. And chlorine is a halogen. It's in group 17. It's going to give us 7 valence electrons. So we're going to add up the total of all the electrons in the molecule. 4 plus 3 is 7, plus 7 gives us a total of 14 valence electrons. That's step 1. Step 2 is to figure out which atom goes in the middle. Well, if I draw out the individual dot diagrams for each of these elements, to figure out which one goes in the middle, we're going to see which one has the most unshared pairs of electron. Carbon has 4 dots that are unshared. In other words, we have just a single dot on each side. Hydrogen has 1 dot that is unshared, and chlorine has lots of dots, but only one of them is unshared. So the one with the most unshared or lone pairs is carbon. That's the one that's going to go in the middle. So I'm going to put carbon in the middle, and then I'm going to connect all the other atoms with a single bonding pair. Now remember, we said that these lines represent a bond or 2 electrons. So each line is equal to 2 dots. Okay? So now we got to check to see if we have all the electrons that we need. Each line equals 2 dots, so let's count all of our electrons. 2, 4, 6, 8. Well, we were hoping to get to 14, so we have some extra unshared pairs. That's step 3. So we're going to put those remaining electrons around our remaining atoms. Now, are they going to go around the hydrogen or the chlorine? Well, hydrogen is an exception to the octet rule. It's already have a full octet. It only has 1 proton, so it can only attract up to 2 electrons. So we're never going to put any extra dots around hydrogen. The extra dots are going to go around chlorine. So let's give chlorine 3 pairs of electrons because this represents a full octet. Remember, this line is 2 electrons, so 2, 4, 6, 8. Chlorine has a full octet. Let's double check to see if we have all the electrons we need. 2, 4, 6, 8, 10, 12, 14. That's the right number of valence electrons, so this is the correct Lewis structure. Okay? All right, let's try ammonia next, NH3. Nitrogen is in group 15. It's going to give us 5 valence electrons. Hydrogen is in group 1. It's going to give us 1 valence electron, but there's 3 of them. So we have a total of 8 valence electrons in this Lewis structure. Okay? Again, that's our first step, is to count the total number of valence electrons. The second step is to figure out which atom goes in the middle. Well, if I draw out my dot structures, hydrogen has 1 unshared pair. Nitrogen has 5 valence electrons. It has 3 unshared pairs. So it has more unshared pairs than hydrogen, so nitrogen's going to go in the middle. We put nitrogen in the middle. Then we're going to connect all the atoms with a single bonding pair, or a line. That's step 2. Okay? So let's count to see if we have the number of valence electrons we need. 2, 4, 6. Well, we were trying to get to 8. So step 3, the extra unshared electron pairs are going to go around our nitrogen atom, because nitrogen's more electronegative. It has a full octet. It needs 8 electrons. So nitrogen has a full octet, 2, 4, 6, 8. And our molecule has the right number of electrons that it needs, 2, 4, 6, 8. That was the number we were hoping to get to, so this is the correct Lewis structure. Okay, let's do our last example. Our last example here is water. Remember, we're going to list all the elements, hydrogen and oxygen. Hydrogen has 1 valence electrons, but there's 2 of them, so we're going to multiply that by 2. Oxygen is in group 16, so it has 6 valence electrons. So 2 plus 6 gives us a total of 8 valence electrons in this molecule. Okay, the next step is to figure out which one goes in the middle. Well, oxygen, group 16, if we draw out its dot structure, it has 2 atoms that have unshared pair. Hydrogen only has 1, so oxygen is going to go in the middle. That's our middle atom. Okay, now I'm going to connect each one of my hydrogen atoms with a single bonding pair. 2, 4. Well, that's not the number we were hoping to get to. So again, we have to add the extra lone pairs around oxygen to give it a full octet. So if I add in 2 additional pairs of electrons, and I count again, 2, 4, 6, 8, oxygen now has a full octet. 2, 4, 6, 8. That's the number that I was hoping to account for in my Lewis structure. That's the number of electrons that I needed. So this is the correct Lewis structure. Okay, so those are just some examples of how to do this process, how to draw out Lewis structures for these covalent molecules.